Good afternoon, ladies and gentlemen. My name is Dorin Pitigoi, and I will use the opportunity that FESPA presented me today to introduce to you what is called Fogra specification for system and process check for large format printing applications. So this is a technical document, basically. I will just briefly introduce all the key aspects related to it. And this is something that was in work for the past several years. In 2012, Fogra launched a concept which was called printing the expected, which was very nicely presenting the market's evolution, where, from happy to get color to colorful wasn't enough anymore. So the need of a so-called global, color quality was need to be defined, especially in relation to the explosion of the digital printing technologies and the digital printing products that were introduced to the market. It's very simple. It's not just the expected. When you look, you have a variety of printing technology, a variety of substrates, you have a variety of production batches and different viewing conditions. And from the point of view of the print buyer, this really needs to be consistent. When you look in this example, you can see various substrates having the same graphic content, and perceptually, this looks very nicely integrated. You have at least 4 different types of printing in this product. So a little bit of background. This work that was done to create this paperwork was mostly provided by the experts working in what is called the Digital Printing Working Group. This is a technical committee hosted by Fogra. And originally it was proposed to become an ISO standard, then it was downgraded to what is called an ISO technical specification. And eventually, because there was a little bit of disagreements between experts, how this is going to be used, it was decided at this year meeting to withdraw the project from the ISO table and create what is called the Fogra technical specification, which is much easier to be published and much easier to be presented to the market. So the concept is very simple. We need to prove that all the metrics and all the parameters that are defined in this paper can be used successfully by the market. We want to get feedback from the market. Of course, it will require some adjustments, some tweaking, and eventually, when we have our homework done, to go back to the ISO and restart the project. This is a public available specification. You can actually download it from this link from the Fogra website. So what is the scope? The scope is to define the requirements and print quality attributes for what is called a digital large format printed product. By implication, we also address the same metrics to the system that were used to produce the respective digital printed product. We also provide a series of test methods and recommendations how these test methods need to be used. From the point of view of applicability, this refers to any roll-to-roll or flatbed or hybrid printing system, regardless of the width of the marking technology. Of course, we don't want to cover everything. So specific things like metallics or ceramics are not covered by this specification. The main driven engine behind this specification is what is called ISO 15311 Part 1, which is basically a collection of different metrics that you can choose from when you want to evaluate the quality and other aspects of your printed product. And the concept is very simple. We are not concerned about how that particular product was made, but actually the results, the product itself, what you actually see and touch and feel. We have 2 governing aspects. So one of them is the final viewing distance, because you don't treat a product in the same way when you see it from half a meter from you or when you see it 50 meters from you. And the second aspect, it's basically where it's used. It's used indoor or it's used outdoor because you have some permanence requirements that need to be fulfilled for how long that product needs to be alive. So we identify two specific use cases for this specification. What is called for printers, for printing system manufacturer, for substrate manufacturer, is called process check or system check. And basically, it's trying to evaluate the whole printing combination that it's made of specific components, like the printing system, like the colorant, like the substrates, how it's actually able to fulfill certain requirements of a specific large format printing application. And the much simple version, which basically is addressing the printers and print buyers, which is called print check, which we look at very specific criteria that can be easily identified in order to pass or fail a certain product. We want to do a standardization. We don't want to limit neither the printing technologies, neither the substrates, neither the colorants. We want to create an environment where actually the quality of the printed product it's more manageable, because the same methods can be applied regardless of how the product was done, how it was printed, how it was assembled. So the main point of this specification is what is called the printing combination. And we are looking at this printing combination and what they can achieve by printing. Our audience, or at least in the way we created this specification, is to address these three main categories. The first one is the print buyers, the one that it's trying to get a certain, it's putting on the table a certain specification and requirements, and he needs to get those requirements fulfilled by the printers. So the relation between print buyers and printers need to be in such a way that they both can objectively identify what is happening with the printed products. The second target is the printer itself, that really need to be prepared for achieving specific type of applications. So in order to do that, he needs to know what he has in the factory, how his printing system, his substrates, his colorants are acting. And in the end, the third category is it's the printing system manufacturer, substrate manufacturer, that they are intended to check if the printing system or the substrate it's really addressing the needs and requirements of a specific or typical signage application. So inside the specification, there are several metrics that are defined. These metrics can be a laboratory metric that requires a certain level of knowledge, a certain level of equipment to properly evaluate the results of such a metric. Then we have the practical methods. These practical methods are basically accessible to the normal, regular tools that we use in large format printing. And even some procedures are still based on a visual observation or appraisal of that result. We simply don't have yet the technological meanings to do it in a more reliable way, so this is still subject to human observer subjectivity. We have two types of checkings. The most simple one is the print check, which is basically an average test where you check a printed sheet. You check its color accuracy, you check its uniformity, you check its details, sharpness, and other rendition capabilities, and so on. And then we have a more exhaustive procedure, which is called system check or process check. And this one, it's passing an entire printing combination to these metrics, and it's giving you a full overview of the result of that specific printing combination. Of course, we have also the permanence requirements, and when the environment factors like light, heat, humidity are relevant, the printed products also needs to be evaluated to see how long it will last or fulfill, a certain level of stability over time. When we look at large format printing application, we see some typical ones that are very obvious, but this is a very dynamic domain. It's always changing. New applications emerge, some old ones are reinvented, and we are having now quite a mixture of, typical large format signage application, blending in with some industrial application, like for example, interior decoration. And this is creating a whole lot of, new areas where large format printing is used. And we simply see these two governing aspects here. We see the viewing distance. There are certain products that are meant to be viewed from the very close range. And then we're having a certain type of products that are always viewed from a very, distant range. But there are products that you can view them also from close range and from distant range. So how we are going to, evaluate such a product that needs to be viewed from different ranges. And of course, we have the indoor and outdoor usage of these products. So we define in there 4 product categories that are based on the viewing distance. We did a little bit of research, checking, what other industries like, TV and movies are doing in this respect. And we found out that basically the optimal viewing distance range ratio is exactly the diagonal of the printed product. So its format, the diagonal of the format of the printed product, it's identical with the optimal viewing distance. And based on that, we did a study trying to find out which are the most common formats available on the market. Of course, there is no standardization in formats. In large format printing, you have such a huge variety of printed formats. But some formats are preferred over others. And you have specific things that are outdoor or indoor that have specific sizes. By observing the bulk of this specific application, we identified these 4 ranges, 4 viewing ranges, and we categorize them. I mean, the names are not necessarily relevant, but we are trying just to pass, the concept, saying, well, the close range, like photo range, this is a close range viewing distance. Then we have the average range, this is the POS category, and then we have the increased range, the banner range, and the distant range, the billboard one. And each one of them has specific intending viewing distances, like up to 1.5 meter for photo, between 1.5 and 5 for POS, and 5 to 15 for banner, and billboard over 15. All the metrics, or most of them, will relate in one way or the other to this viewing distance. So, first of all, we need to establish the measurement protocol. We measure the same way we see it. We have an ISO standard, the 13655, that is applicable to graphic technology, large format printing including. Typically, we have a measurement condition. In large format printing, we mostly rely on M0 and M1, and the backing to be used, either white or black. And usually, these ones are specified, but so-called the reference printing condition, because in large format printing, we use the meanings of color management to achieve the relation between input and output of the printing process. Now, the idea and limitation of this specification, it's based on the fact that we need to have a meaningful interpretation of our measurement. So this means very simple. It needs to be correlated with the observer perception. So every measurement we are doing in the framework of this specification need to be consistent with the visual observer appraisal of the same product. And this is applicable for what is called the reflected responses. This is a 45-0-0-45 geometries. And for transmitted response, which is a diffuse 0-degree geometry. Of course, in order to achieve this, I have a correlation between measurement and visual appraisal. We need to have a viewing booth or a transparency light box that is compliant with ISO 3664, because this is the only way where we create the viewing condition for the observer to be consistent with the colorimetrical measurements that resulted from the metrological protocol. Mostly into this category are so-called paper-like substrates or isotropic substrates. But we still have provision inside the specification for non-paper-like, non-isotropic substrates. And we develop a so-called visual plausibility test method that's correlated with the proper built-up metrological protocol, allows you to measure substrates that are not typically measured. And tomorrow I will have another presentation that show how different substrates like low opacity textile or perforated substrates can be successfully measured by using a 45-0-degree measurement device. One of the most important aspects of the metrological protocol is its data consistency and quality. They are very important factors, and the whole procedure needs to be established in such a way that your measurements are reliable. And in order to do this, you need to do a lot of averaging, you need to do smoothing, you need to use your large aperture measurement device. Not all the substrates can be measurement with a small or medium-sized aperture device. Some scanning measurement devices, they are able to create a so-called virtual aperture by doing a lot of averaging while they are in scanning mode. We define this digital print combination key indicators. We say we need a reference printing condition, and we need to define the quality level, A, B, C. This is typical for many ISO standards to have a classification, how close you are to a certain specification. We need to define how it's observed or appreciated. It's a media absolute or a side-by-side media relative evaluation. We need to define the printing system. We need to define the substrate. We need to define the color management software, the workflow that it's used, and also the intended viewing distance. All these parameters are defining a digital printing combination in a unique way. Data delivery. This is very important. As all the new ISO standard related to graphic technology, we are strongly encourage the market to use the PDFX, and especially the PDFX4 format, because it's very reliable. And it's recommended to use the guidelines from different organizations like Ghent Workgroup or PDF6 Ready Association. We have created dedicated pre-flight check for digital printing products. Actually, for the past year, Fogra ran a so-called form where you can put the most relevant aspects related to digital printing workflow for both small format printing and large format printing. And already based on the feedback that we got from the small format printing, we have published a PDFX ready pre-flight profile and creation for small format printing. And the large format printing one is following up as soon as more input is provided. We also have an annex in this specification related to so-called informative recommendation how to optimize a PDF when the data contained in that PDF it's either ambiguous or it's coming from an office application. So basically a type of PDF that is not containing proper defined information to be processed and exchanged between pre-press and press. Of course, one of the most important aspects in a printed product, it's what is called color accuracy. I mean, how close it's the printed product in relation to the reference printing condition. And we have here two types of evaluation. A practical one, which is based on a small subset, like a media wedge, so a limited number of patches that you measure and you check against the reference printing condition. And then you have an extended scrutiny, that it's using a more, larger batch of information, like an ISO 12602 Part 2 chart, which contains many patches. And then it's also important how you do the evaluation. And we define two ways to do that. We define the absolute, the full color reproduction. This is basically a similar type of reproduction like a contract proof, for example, where you are aiming to very accurately reproduce color. And then we are having a so-called media relative, when you evaluate basically the color, but you take into account the relation between the substrates that is defined in the reference printing condition and the output printing condition. From the point of view of metrological protocol, we find out that in large format printing, it's very important not only how, but what you measure. And one of the reasons that Fogra created a special version for large format printing, it's exactly because we have limitation and we need a much larger area to get the measurement than from a regular patch size. So one of the key points is to have wider patch sizes. This is very easy to explain. Most of the strip mode scanning devices, they are doing a lot of measurements per second. They are continuously illuminating the target area and they are taking a lot of measurements, over 200. And they have built-in algorithms to average this measurement, and this is basically giving you a more reliable way of measuring something. Also, if the patches have a difference, a color difference of over 5 delta E, typically you don't need separators. So all these scanning devices are able to jump to the next patch in a very easy way. I mean, even if you print such a media wedge on a very big droplet size, large format printer, and you measure it with an i1 Pro, for example, you will still be able to measure it because the device will discriminate the delta E jump between two adjacent patches. Such a chart is usually read by any measurement device, so it doesn't matter if it's from Barbieri or from Konica Minolta or from X-Rite, you would be able to read such a media wedge. And based on this experience, we develop inside Digital Printing Working Group what is called the Universal LFP chart. This is basically a 12 A4 pages chart that can be assembled together or they can be printed as individual pages. It contains the original ISO 12642 Part 2 patches, plus additional patches for uniformity check. And you can download it also from Fogra website. And you can use it for profiling or from extended scrutiny based on this specification. Now, getting back to our color accuracy tolerances of both media absolute and media relative. The initial publication of what is called the Process Standard Digital Industrial Procedure was using an approach that was more oriented to contract proofing. And over the years, we realized that the current procedure, it's a little bit difficult to apply and has some limitation. So it was proposed at this year meeting of Digital Printing Working Group to tweak these tolerances and to make them much easier to be applied in practice. First of all, we are using the delta E 2000 formula. This is much better visual correlated than delta E 76 or delta EAB. And for substrate, the initial publication of PSD was having different criteria for ABC levels. Now we said that we have the same criteria for all levels. So this is the 3 delta E 2000 threshold. And as soon as you're exceeding this 3 delta E, you're basically no longer able to evaluate something from the point of view of media absolute. Simply put, the white point difference is too big for the two products to be saw or appreciated side by side. Then we realized that the maximum and the delta H is not a reliable way to evaluate. So we simply got rid of them and we replaced them with a so-called 95% percentile, and we simply gave up to the delta H's. We also modified the values, so the difference for each class is not 1 level, but 2. This is because the inter-instrument agreement or intermodal agreement of the current available devices on the market is not good enough to allow such a tight tolerances. For media relative, basically, it's the same as the media absolute, but the differences are in relation to the substrate difference. If the 3 delta E is passed, then we really need to do a media relative evaluation. Also, you can see on this column the new modification that will be integrated in the contract proofing standard, the so-known ISO 12647 Part 7. And the values here that are related to this specification will actually be adjusted as soon as the one from contract proofing will be adjusted too. So as soon as this column will get their final values, we are going to tweak again the proposed values for the large format printing. We don't want to make our A quality, which is basically the most accurate reproduction in large format digital printing, to be more thorough than a contract proof. We also introduce a specific requirement for spot color, because this is becoming more and more interesting to be reproduced in large format printing. We are seeing brand owners, spot color specification being requested to be very accurately reproduced in large format printing. So again, we are proposing the 3 threshold, the level A, B, C, but we also have to take into account the current value from the draft of the ISO 13647 Part 7. When it comes to spot colors, it's very important to define them. I mean, you cannot simply reproduce the color where you don't know where it's coming from. So you need to have a specific library when you know the color just by name, or you need to have a CXF file that will have a digital representation of that particular spot color. So unambiguous communication of the spot colors is very important. We are also seeing that the quality of the reproduction in terms of color accuracy of the spot colors is completely dependent of your output printing condition, because here in large format printing we are not going to use a single colorant to reproduce that spot color. We are going to use a process color reproduction. We are using the main process color of our printing system to simulate the same color as the reference one. And if the output printing condition is not correctly characterized, then our spot color reproduction will suffer as a result of this problem. Other color-related requirements. We have a requirement for short and long-term repeatability. I mean, how printing system is able to be consistent in a short term and in long term. We have also variation tolerances. Here it's a very tricky aspect, because this is mostly related to what is called quality assurance, and this varies from printer to printer to printer buyer to printer buyer. But in general, as soon as you start sampling your production batches for more measurements and you look at how your batch was reproduced, then you really need to measure everything in order to understand how your reproduction eventually came out of your printing process. We also have a requirement for tone value reproduction limits. This is typical coming from conventional printing, where you have a specific ranges of tones that you want to reproduce. And this is mostly informative, but we would like, depending on the viewing range, to see as much of the tone reproduced from the reference to the output printing condition. We also want to have a tone smoothness. This is a visual evaluation of what is called a vignette. You have the gradation of your primary colors or your secondary colors, and you simply visually check not to have, non-uniformities. Then we have the number of tonal steps, which is also called the P-score. How many distinct tones, a printing combination is able to reproduce. And Fogra developed specific methods that you can find more information on the link that you are seeing there. Gloss, it's another interesting topic. Usually our reference printing condition doesn't have any definition of the gloss. This can be known externally and by meaning of a classification like a matte or a semi-gloss or gloss level. But as a general rule, you like that your process color, your colorants, to have the same gloss level. And in general, you don't want to have a difference between the gloss level of your substrates and the gloss level of your colorant. They need to be consistent. Otherwise, for close range viewing distance, the observer will perceive the difference in the gloss of the colorant and of the substrate. The next category of information that we would like to assess is the uniformity or homogeneity. Of course, this is a very subjective impression, but we still have, methods to determine from measurements how good a printing system or a printing combination is able to maintain its uniformity. But in order to do that, in large format printing, we have specific requirements how you build up the layout. Because we are going to evaluate, the same thing over and over, the printing width. And the printing width is more relevant than the substrate feeding direction in large format printing. So the relevance of one axis over the other, it's more important. So we describe a schema, how you are going to do the imposition of the test charts over such a large format printing system. We have the large area uniformity. This is basically, you have a patch, at least one patch, but you can have more. You can have different same media wedge, but printed in different position over the printing width. And you simply evaluate the relation between any of these patches and the average of all the patches of the same time that you can find on your printing area. We also have a strictness information. This is a visual method. You simply look for, bands that appears on your print. And then you have the motor and graininess, which usually indicate a problem in the printing system. Something like you are having bleeding, for example. This is or coalescence. This results usually in a motor effect. Or your print heads are not aligned between them, or your print height is not in the proper relation to the substrate. Then we have a more reliable ways to evaluate the macro uniformity. It's called the M-score. This is done based on the method that Fogra developed. You can find a lot of information, what it means and how it needs to be used on Fogra website. And basically means that you need to print these charts, you need to measure them, and the algorithm will calculate the uniformity of the printed areas. Then we have an extension for graininess, because based on the viewing distance, you may have the same color difference, but when you look at the geometrical aspect of the reproduction, you can see very easily the difference between a small dot printing system and a high dot printing system. And graininess is a very good way to evaluate the suitability of a printing combination in relation to the viewing distance. Detailed rendition capabilities. We all know what the resolution is, but the effective resolution is not always as the perceived one. And there are many aspects. For example, the sharpness of a printer refers to the capability of that particular printer to produce a distinct edge, while the resolution of the printers refer to the ability or capability to produce fine details. So they do refer to somewhat different things. For this, Fogra developed a specific method which is called the L-score. Again, you can find more information on the website. And we have recommended and typical values for all the categories of the printed product. Other information, line width, line blurriness, line ruggedness, native addressability. This is the real resolution of the printing system. And then we have the effective addressability, which is basically the apparent resolution of the printing system. We may have also informative information like checking the bleeding, if there's an over-inking of the printing combination. Color registration. This is basically showing how accurately print heads are aligned between them. And typically we have different types of positioning. We have an image to image. This is all color planes in relation to each other. When we have an image to edge, how the image, it's a perfect square or it's deformed. And then we have a front side to back side. In large format printing, it's not that common to print on both sides. It's in general a rare type of applications, and we don't have enough feedback for image to edge and front side to back side to provide numerical typical values. So far, we have the misregistration, which basically it's the print head misalignment, and again, we have recommended values for the product categories. And then we have artifacts. These are things that does not supposed to be in the reproduction, but they are still there. And we may have contouring, we may have satellite dots. We may have different effects like shines through or strikes through, how much ink penetrated the substrates and ended up on the other side, and so on. Of course, there are some other specific criteria that print buyers may require from printers, but these need to be agreed and communicated between them. Permanence. Again, we have this second governing aspect, where the printed products will be viewed. It will be viewed indoor or it will be viewed outdoor. And in relation to this, a lot of things can be evaluated. These in general are laboratory methods that requires application of different methods to accelerate the aging of the printed products and to determine its lifetime. Of course, we have the indoor light stability, we have the weathering, the thermal stability, print life expectation, water resistance, scratch resistant, and so on. All of these methods have specific laboratory testing procedures that need to be applied in order to determine its suitability. We also have a recommendation in respect to so-called margin information. This is basically a job ticket that you would like to associate your printed products in order to determine what you are seeing. I mean, it's just a colorful reproduction or it's something that was done in a specific way. And in order to identify that, we recommend that you have your color reference. So this is the reference printing condition, that you are doing either absolute or media relative evaluation. You want to know the file name. You want to know the printing system that it was done, the substrate designation, the printing mode. In large format printing, you have a printing system that has a variety of combination it can print with. And then the printing conditions that need to be simulated, and of course, the time and date of a production, because you may have different batches and you want to identify each one of them properly. Additionally, you can put whatever you think is useful, like you put the time and date of the last calibration so you can keep track of your process control information. You have the colorant name. Maybe your printing system is using, two different types of colorants and you want to know which one was used. You have your specific color management profiles and different other aspects like spot color names if you use them. You have the workflow, the production workflow that was used to drive on the printing system. You have the scaling of the document. You have a coating and so on. All of this information, you think it's useful, you can put it in such a job ticket, and every time you look at the printing sheet, you know how it was done. In large format printing, it's much easier to do this because you can print basically each individual copy with the proper information you would like to have. Now, in order to validate this specification, because the whole point of withdrawing it from the ISO table and put it in as a Fogra specification is to get feedback from the market and to encourage printers and print buyers and any other interested parties to use it. So we have two main questions here. First of all, do the viewing distance category, are these viewing distances proper? Do they fit the market requirements for specific printed products? The second question, do the current metrics and the current tolerances properly, describe what is happening there? Can we work with those tolerances? On the Fogra website, you can find a link here where you can access a complete test form. You can print that and you can submit these test samples to Fogra where they will be evaluated. The purpose of this project is, first of all, to let you know how you stand. And then if you have a specific product or a specific application, and you know that this is, let's say, a banner or it's a POS, POP application, then we simply check if the criteria and methods defined are fulfilling your products. Thank you very much for your attention. If you have any question, I will be happy to answer to you.